Okay, to save the already created figures, let's try to see how we can actually do that. Let's first copy and paste the plot that we have already created. So now instead of plt.show, we can actually save the figure. It's plt.savefig, and I have specified the path where I have saved that figure, or you can just save it here on the local directory as well. So it's saved of type.png. You can specify the type as jpg, jpeg, pdf, depending on your requirement. You can essentially save it as .svg file as well. So if we just look at the method and press the shift plus tab, you can see different type of arguments that this method can actually take. You can just play around with them depending on your requirement. You can use any of them. DPI, as you can see, that's the dots per inch. It takes the quality argument as well, which we are now going to see very shortly. Pad inches, frame on, etc. You can specify the edge color as well. So here for the quality, it has specified that on the 1 it's the worst, and on the 95 it's the best. Also for like DPI, as it relates to the resolution of the image, like 300 is the default, and you can specify 1200 and so on for a better, sharper image. Format you can pick up as PNG, PDF, or SVG. Okay, let's change the extension to PDF, and now let's see whether it got saved as PDF or not. So I have just executed this statement, and if we check the directory, so I can see the PDF being saved there. If I try to change it into a different format, say SVG, and execute the statement again, so I can pretty much, if I see the directory, I can actually verify that it is being saved as SVG. Maybe you can try that on your local machine. Okay, if we now specify additional arguments, so we have DPI quality as we have seen earlier. So by default, the DPI is none actually. And the quality, as you can see, it should be between 1 to 95 for the best results. Okay, let's specify the quality as 95 here. Let's just check how the best quality actually looks before we try out the worst one. Okay, so it says that it's not longer supported as of 3.3, and it only works for JPG and JPEG type of images. So let's here change the extension of the figure 1 to JPG instead of PNG, and just execute the statement. If I do check it on my directory, the quality of the image looks fine to me. Let's change the quality to 1 and the figure to figure 2 just to differentiate. If I do again look it into my directory, then I can definitely see the quality is not that good. Quality 50 appears a bit fine to me. Okay, now let's see how we can actually just have this figure in a local directory that is on Jupyter Notebook. So I'm just going to copy paste the above code and instead of the path to the directory, let's just put the figure name. So by default, it's going to save in our local directory here at the Jupyter Notebook. So let's put it as figure 2. So instead of quality, now let's test it with the DPI, that's the dots per inch. So now let's maybe put it as 200. And if we do execute the statement, let's just copy these lines and put the DPI as 1200. So and save the figure accordingly so that we can see the difference between the two figures. So the figure 2 is with the DPI 200, figure 3 is with the DPI 1200. You can use the ls command to actually list what kind of figures you have in your directory. So if we look at the figure 2, that's how the figure 2 actually looks like. And if you look at the figure 3, it's a bit larger and more clearer as well. You can definitely play around with these at your own PC, at your own local directory, and see how DPI actually displays image.